Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to find the limiting sum of a geometric series. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one. So we need to find the value of x for this limiting sum is equal to 19 and 1/5. So first of all, to find limiting sum, so we know that the formula for this is s of infinity is equal to a 1 minus r. There you go. Okay, so we know that a, let me just write these values down first. A is 12. And to work out the r, that is the common ratio. So r is, let's just use term 2, which is 12x divided by term 1, which is 12. Then therefore we cancel this out. So therefore the common ratio is x. So there you go. So now we just use the formula. So s of infinity is equal to a 1 minus r. And we know that the limiting sum is 19 and 1/5. 19 and 1/5 is equal to a, which is 12 over 1 minus x. Now to solve this equation, what I do, I just convert 19 and 1/5 into improper fraction first. So I just go fractions, shift fractions, 19 and 1 over 5. Press equal. So 96 over 5. So 96 over 5 is equal to 12, 1 minus x. So what I do now is I just do cross multiply. So that is, we cross multiply. So that is 96 we times by 1 minus x, which is equal to 12 times 5. So 12 times 5 is 60. So I just write 60. So now what I do, I remove the bracket. So 1 times 96 is 96. 96 times negative x will give me minus 96x, which is equal to 60. So what I do now is I move this negative 96x on this side and 60 move on that side. So that becomes 96 minus 60. So 90 minus 60 is 30. So 36. Okay. So 36 is equal to, so the negative 96x move on this side becomes positive 96x. So now I just divide by both sides by 96. So which is 96 here and 96 here. So there you go. What I do, I just put down on a calculator. So what I do, I just go 36 over 96. So there you go. So x is equal to 3 over 8. So therefore, x is equal to 3/8. So there you go. Second questions. So we need to find the value of x so that the limiting sum for this series to be exist. So in order to do that, so we know that the limiting sum to exist, the common ratio must be between -1 and 1. So in another word, r is greater than -1 and less than 1. So keep that in mind. So now I just find the common ratio first. That is r. So r is equal to term 2, 1 over x squared, we divide by term 1. So that term 1 is 1 over x. So that is exactly the same as 1 over x squared times by, we flip the second fraction. So 1 over x, we flip that, becomes x over 1. So now what I do, I cross this out. So that give me x. So therefore, on the numerator, so that's left with 1. So 1 times 1, give me 1. And x times 1 is x. So there you go. So this means that we know that r is between -1 and 1. So this means that 1 over x is between -1 and 1. So rather solve this by algebraically, so I can just solve this by graphically, is easier, that's all. So this is 1 over x. And this is y is equal to 1. Just a quick sketch. Now we can find the point of intersection here. So this one here is 1 over x, and this is y equal 1. So when they intersect, that means they equal each other. So 1 over x is 1. So therefore, we can just, by inspections, 1 over 1 is 1, right? So x must be equal to 1. So this one here is x is equal to 1. And for y equal -1, just a rough sketch here. So this is -1 here. So we can find the point of intersection here. So therefore, this is also 1 over x. So to solve this, we can just quickly write here 1 over x is equal to -1. So this means that x must be equal to -1. So 1 over -1 will give me -1. So this is -1. So that is the point of intersections. Now for 1 over x is less than 1. So we have this part here, less than 1, and this graph less than 1. And for 1 over x greater than -1, so we have this part here. So greater than -1. So there you go. That is the answer. So therefore, we know that the final products, that is x is less than -1 or x is greater than 1. So there you go. So that is the answer. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, we know that r must be between -1 and 1 for limiting sum to exist, okay? So we just need to find the common ratio, that is r. So r is, can you term 2 over term 1 or term 3 over term 2 if you like. So let me just write this down here. The common ratio is term 2, which is x squared, over term 1, which is x. So we can cancel this out, which is x over 1. So therefore, r is equal to x. So this means that the conditions for the limiting sum to exist is when x is greater than -1 or less than 1. So there you go. That's the answer. Last one. So we need to find the value of x so that the sum of this series is equal to 9. And we know that the limiting sum, that is sum of infinity, the rule is a over 1 minus r. And we know that r, the common ratio, is term 2, that is 2x over 3, divided by term 1, that is x, divided by x, is exactly the same as term 1 over x, if you like. So now we just cancel this x. So therefore, the answer is 2 over 3. So therefore, sum of infinity, which is equal to 9. So it's 9 is equal to a is x, over 1 minus the common ratio, that is 2/3. So 2/3. So now 1 minus 2/3 will give me 1/3. So on this left hand side here, I just write this down. Equal x over 1 over 3. So now to solve this, what I do, I just times 1/3 on both sides. So I just times 1/3 on this side, and I need to times by 1/3 on this side as well. So now this is cancelled with this. So therefore 1/3 of 9 is 3. So therefore x is equal to 3. So there you go. And I hope you got all of them correct. And thank you so much for watching. Bye.